Okay. Okay, students, good morning. Now we'll continue with the triangles. I hope you have done 7.3. Any doubts in 7.3 you can ask me. Good. No doubts? Harshal, Suti, any doubts are there in 7.3? Okay, I think no doubt. Good. So shall we proceed now further? Okay, now we'll see here. We'll go to the next part, that is inequalities in a triangle. Okay, these inequalities means which are not equal. They are called inequalities, right? So what happens in a triangle? You know that there is a triangle. Always in a triangle, the sum of any two sides is greater than or equal to third side. The sum of any two sides of a triangle, that means AB plus BC is greater than AC, AC plus BC is greater than equal to AB, or AB plus CA is greater than equal to BC. This is a valid condition, right? So this is a very fundamental condition that how the sum of the angles of a triangle is 180. That should be condition, okay? Interior angles. Is always 180. These are the primary conditions to form a triangle. If it is more than 180 or less than 180, the construction of triangle is not possible. It will not be a closed figure or a closed polygon. You understand? You try it. If it is more than 180, you will not get a triangle. If it is less than 180, you will not get a triangle. And if you try sides of the triangle 2, 3, 4, you will not get a triangle because sum of two sides is less than the greater than equal to third side. Okay. So here 3 plus 4 greater than equal to 2. 2 plus 4 greater than equal to 3. Suppose 1, 2, 3 you take here, or 1 to 4. 1 and 2 greater than less than equal to 4. So this here you cannot construct the triangle. Not possible to construct because every pair you have to see sum of two sides is greater than equal to third side. Why? Because here 1 plus 2 is less than 4. That's why you will not get the intersection point of third vertex. You will get only base. Okay, you can draw here 4, AB, and here 2, and here 1. How will you get a triangle? If they will intersect only, you will get a triangle or not. So the construction of triangle is possible only when with this condition, and angles there is a condition, and sides also there is a condition. So these are called inequalities in a triangle, right? So every triangle must and should hold this criteria, right? sum of two sides is greater than or equal to third side, or the sum of the interior angles of a triangle is 180 degrees, neither less than 180 nor more than 180 degrees. So this part is very fundamental, that if any pair of sides of triangle not satisfying the condition does not yield to a triangle. So now again note of this one. So conditions for forming a triangle, inequalities. Okay. So always in a triangle there must be sum of two sides greater than or equal to the third side. In the other case, the sum of the angles, which are nothing but interior angles of a triangle, must be equal to 180 degrees. These two are the fundamental conditions to satisfy. Are you clear? Now you can make a note of this. Based on this, we'll go for the in a triangle. We'll take the relation between sides and opposite angles, as well as angles and opposite sides. Because already we know there is one-to-one correspondence between the sides and angles of a triangle. So note on this part. First you note down, then we proceed to that. Right? So we'll proceed next. Always, this also we know already, there is one-to-one correspondence between sides and opposite angles, as well as angles and opposite sides of a. You remember, always there is one-to-one correspondence between the sides and opposite angles, okay, and as well as angles and opposite sides. If you take with the angle, it will be corresponding to the opposite angle, and if you take the angle, you will be taking the corresponding side opposite to the angle. Suppose you take an angle. This is a right angle triangle. Okay. These are not according to proof. For example, in right triangle ABC, angle B is equal to 90 degrees, the largest angle, right or not? Then AC side opposite to angle B is hypotenuse, is clearly largest side of all AB, AC and BC. Okay, you know, because it's a largest angle, because these two must be 180, these two should be equivalent if it is 90 degree. Opposite angle, what is the side? By hypotenuse theorem or by Pythagoras theorem, since AC square is equal to AB square plus BC square, clearly AB must be less than AC and BC must be less than AC. by Pythagoras theorem. Hence, this is valid. So, what you can say? In a triangle, side opposite to larger angle is the larger. Automatically, this will be remain. Next is BC. Suppose angle is next larger. Next angle C is smaller. So here this is smaller. Similarly, angle opposite to longer side, smallest angle is the smaller side. Likewise, versa, you can take. Note down this one. So this relation will be always hold good, right? Okay, note down. So by this clearly, we can in an equilateral triangle, you take another example. Okay. Also, in triangle ABC, if angle A is equal to 50 degrees, angle C is equal to 40 degrees, therefore, opposite to angle A, the side is BC larger than opposite to angle B, angle C, the side AB. Since angle A is greater than angle C, A opposite is BC is greater than AB. So how to know without triangle figure? If you want to know side opposite to angle A, exclude this A, you will get BC. Because in triangle ABC, three vertices are there. So opposite to side angle C, you want to know side is AB. So automatically if A is equal to greater than C, then BC is greater than AB. And automatically AC is the largest side because angle B is 90, the largest angle. Okay, note down. Write down. Okay. Right. Now I'm erasing this part. In a scalene triangle ABC, this is 70, this is 60, this is 50. Okay, and A is 70 degrees, implies BC is the largest side. Angle C is equal to 60 degrees, implies AB is the second largest side. Similarly, angle B is equal to 50 degrees, implies AC is the smallest side. Okay, since angles A, B, C are different sides. A, B, B, C and CA are also different. Hence, triangle ABC is scalene. Also, triangle ABC is a acute angled triangle since all the angles are less than 90 and are acute. Now you understood now? See, you are taking the triangle ABC. According to angles, the opposite sides are largest. This is the largest one, and this is the second largest, and this is the third largest, means smallest one. So depend. Because 50 is the smallest, so automatically you see the side is smallest. 70 is the largest, so side is largest. Then immediately. So this is 5, this is some 4.8 or 4.7, this is some 3.2 like that. Okay, so anyway you take the corresponding relation between the sides and opposite angles as well as angles and opposite sides must be valid or hold good. Means sides opposite the largest angle are larger and angle opposite the largest side is larger. Similarly, side opposite the smallest angle is smaller or the smallest, and angle opposite the smallest side is smallest. Okay, in the case of scale, we have seen right angle, we have seen. Next, we will go for right angle, equilateral triangle. That also will check it. Okay, so note down this part. So you understood the relation between the sides and opposite angles? Are you clear? Okay, now let's see the next case. Now, in an equilateral triangle, we take the equilateral triangle case. Okay, in an equilateral triangle, so in an equilateral triangle, you know, all the sides and all the angles are equal, right? All the sides are equal and all the angles also equal. Why? Because this relation, how do you know it? In an equilateral triangle, all the angles are equal. Each angle is equal to 60. That implies each side is equal to, since angle A is equal to angle B is equal to angle C is equal to 60 degrees, implies BC is equal to CA is equal to AB. Because again, it's showing the one-to-one correspondence between the angles and opposite sides. Suppose you take an isosceles triangle, what happens? PQR. Sides PQ is equal to PR. So remove the corresponding. Angle Q is equal to angle R. These two opposite angles are, this already we proved yesterday. Sides opposite equal, angles are equal, angles opposite equal, sides are equal. This already we proved yesterday. Since angles opposite to equal sides are equal, sides opposite to equal angles are equal. So isosceles triangle, two sides are equal because two angles are equal, and equilateral triangle, all the three sides are equal, so all the three angles are equal. So the relation between the inequalities means neither the sides are equal nor the angles are equal, but different sides which are unequal, they have different angles opposite to them. Similarly, different angles which are unequal have unequal sides opposite to them. So the relation between the sides and opposite angles is always holding good, as the relation between the sides and angles remains standard. So we have seen example with respect to equilateral triangle, isosceles triangle, right angle triangle, scalene triangle. So obtuse angle triangle also, if you take one angle is more than 90. So opposite to one angle, that which is obtuse, that must be the largest side. So other two angles depending upon the, suppose one is 110, other is 40, and other is 30, because 180 should be the sum of the angles. So after 110, side opposite to 40 degrees must be larger. Then lastly, the smallest side is side opposite to angle 30 degrees. So this relation, no need to prove, automatically this is a formation, because a triangle has 6 parts which are 3 sides and 3 angles. And without this relation or inequality holding good, you cannot frame a triangle. This is a fundamental condition. So these are all obvious proofs, and you need to know the relation and then apply it. Now, the next exercise is 7.4 is completely based upon this triangular inequality of sides and inequality of angles. That is based upon exercise 7.4 completely. So we'll see some examples before that. So what you do is that go through example 7, page number 131. Page 131, example 9 you go and you study, try it, understand. If you don't understand, I'll explain this part, and try to complete 7.4 exercise. Okay, tomorrow I'll teach the doubts. Any doubts are there, I'll explain you. Okay, so go through example 9, right? Try to solve exercise 7.4. Tomorrow I will clarify doubts. Okay, any more doubts? Some of you have sent me the project, so others try to complete the project by this month. Okay, good. Okay, try to have your standard of your project must be completely individual and unique of yours. Don't try to copy anything. Okay. And you ask me if you have any doubt. Next, we are left with only two topics, that is chapter 8 quadrilaterals and chapter 9 circles. Okay.